Hello everyone, myself V.V.Gopala, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to tell you about IP version 4. It is a protocol related to Internet Protocol, which is actually the protocol which is familiar in network layer. Because in the OSI model there are several layers. We have 7 layers in the OSI model. In that, network layer is a third layer, and above that there is a transport layer. Of course, every layer is having certain functionalities. In this network layer, we are going to find out a protocol called as Internet Protocol, and in that there are certain versions. Now we are going to deal in this lesson about IP version 4. So actually, after completion of the lesson, so I hope that the student will be able to know about introduction of Internet Protocol, and about the how IP addressing is possible and how it is going to useful for the actual transmission, and also about the structure of IP version 4 header format, and also function of each and every field existing in the IP version 4. So that is about today's lesson I am going to explain to you. And of course, let us start with actually the actual point of Internet Protocol. So Internet Protocol is a protocol basically means set of rules are there to conduct the transmission in a successful manner. So the Internet Protocol is the principal network layer protocol used to deliver packets between hosts across different networks. Because you are going to see various networks, and you are also going to see number of devices which can be identified as the hosts. That means a device from where the actual message is generated and ready to transmit, and once it is released by the sender, so it is going to travel throughout the medium by touching each and every host in between the source and the destination, and finally it has to reach the destination host. So like that, the data in the form of a packet will travel from host to host. Finally it is going to reach the destination. So for that, to conduct the transaction in a successful manner, in a comfortable manner, so there should be some kind of a protocol which can govern all the steps in a perfect manner, so that IP is playing a very important role as far as the network layer is concerned. So it provides a connectionless service, and also it does not give you any guarantee that the delivery is properly possible or not. It won't give you any guarantee, and also it will not follow any kind of order, because the packet may be the fragmented, so that there is no guarantee that the packets that are released will go to the destination in the same order or not. There is no guarantee at all, because it is connectionless kind of a service, and also it will not look after the errors that are occurred during the transmission. So of course these are the problems or the challenges you can find out. But of course basically we are going for a connectionless kind of a service, so that we have to stick on to this kind of possibilities, so that we have to conduct the transaction in a successful manner finally. Of course, in this case of the IP, which is basically a connectionless service, means so here there will not be any kind of a virtual circuit that is going to establish between the hosts. So there is a what you can say, there is a connectionless kind of that means there will not be any connection that will be established, so that all the packets will travel in the same path. So that kind of thing is not possible. So here the routers are are actually doing a job of sending the packets in various directions, and they are allowing the packets to reach the destination by following different routes. So that is actually happening in this case of the IP protocol. So that is why it is called as a connectionless and not a reliable kind of a communication protocol. But even then, because it is very difficult to go for connection oriented, or difficult for reliable kind of a service, always it is difficult for us to establish, because it is very expensive. So we have to go for an alternative. That is the reason, even it is connectionless, even it is not give any guarantee, but we try to establish, and we are going to try this kind of a transaction by using this IP protocol. So, and of course for this IP, there is one important thing that is to be considered, that is called addressing. Because address is something to identify the devices, both the sender and the receiver, so that the devices, even though which are not exactly the source or destination, even though they have the chance of identifying the packet, because by noticing the address and by examining the address whether the packet belongs to them or not, based on that they are able to understand whether to hold it or whether to forward it to the next side. So that is why the address is a very crucial part by which the actual transaction can be carried out in a successful manner from the source to the proper destination. That is why address is a very important what you can say, a part of the complete transaction. So here the host wants to send a datagram, it passes the datagram to its link. How actually the datagram is a word that is used here. That means a part of the total message can be called as a datagram. Suppose you have 10 MB or you have 10 bytes of data. Let us say the 10 bytes of data can be fragmented into 1 byte each. So every 1 byte of information can be here called as a datagram here. The total 10 bytes can be called as a total message. Let us imagine in a simple example so that you can understand what actually the meaning of a datagram. So that is about the datagram, and of course the datagram should be placed in a link. A link is nothing but a medium through which it can travel. So suppose the link is there, and the host is actually directly connected to the link, and the boundary is called as an interface. That means the actual the boundary between the link and the host can be here referred as an interface. That means by using the interface, there can be some transaction that can take place between the host and the link, so that the link can be able to take up the information in the form of a datagram, and it can allow the datagram to travel in the medium. So that is about the actual process in this case of the IP protocol. So now in this let us again introduce a router. The role of a router already we have seen in the previous session. The router is a device which is going to do certain important functions. One is called as deciding about the path, best path, and also provide a temporary connection between the devices is one of the important functions of the router. So there are so many functions, but out of that, these are the very fundamental and very important and crucial functions of the router. Means establish a best path to travel, to allow the packets to travel in that best path, and moreover, it is going to provide a temporary connection between the devices like a switch. What actually it is also a device which is going to provide a temporary connection between the devices, because providing a permanent connection is always expensive, and that is why we are going for an alternative. Thereby we are taking the help of a router by which you can able to provide a temporary connection between the devices. So that is also one of the important point you can consider. In this interface, sometimes you can also place a router so that the router can able to do its job to conduct the transaction in a successful manner. So now in this case of IP addressing, which is a mandatory thing, because it is very useful to identify the concerned sender and receiver, or the source and destination, so that the communication can takes place among the genuine devices in the overall transaction. So that is why IP addressing is mandatory for every interface to enable communication. So IP addresses are essentially essential for identifying devices on a network. Already we have mentioned this in the previous one. It is basically to identify the exact device which is concerned to the actual handing over or taking over the information from the actual medium or a link. So that is why it is very useful. And basically in the network layer, IP addresses are classified into two. They are IP version 4 and IP version 6. Earlier IP version 4 is the header, or it is an address format that is designed, but in this IP version 4, for actually indicating the address of the source and destination, 32 bits is actually used. 32 bits of size is used to indicate the source address and destination address separately. We'll see that in the actual header format, what actually the IP version 4 is going to establish or going to represent the address of address of the source and destination we can see in the slide. And of course, IP version 8 is the extension of IP version 4. IP version 6 is the extension of IP version 4, where the address is slightly extended to 128 bits, so that so more number of identifications or more number of designations can be given to more number of devices. So that is why IP version 6 is more and more prominent to incorporate or to cover more number of devices, to call them by their addresses, so that IP version 6 is going to cover more number of devices. So this is the main difference between IP version 4 and IP version 6, but more or less the functionalities of these two, IP version 4 and IP version 6, are similar, with light modifications in the fields and their role in the actual transaction. So now I hope that on the screen you are able to identify the IP version 4 header format. So in this there are number of fields we have. Every field is going to play a very important role, and of course the size of the that means width wise, if you see that it is of 32 bits of size. It is also indicated on the screen. So that is the 32 bits of size. That means any row you consider, the total length is 32 bytes, 32 bits, sorry. In this case of 32 bits, so it is actually fragmented into a number of rows. So any row you consider, it is totally 32 bits. But from the first row to the fifth row, let us say, so up to this, there are 5 rows we are finding, because in every row you are saying that it is 32 bits, means if you want to note down in terms of bytes, better you divide that by 8 bits, so that because 1 byte is equal to 8 bits, so that you can able to identify these 32 bits in terms of bytes as 4 bytes. That means every row is indicating 4 bytes of information. So like that there are 5 rows we have totally. So 4 bytes into 5 rows, so which is equal to 20 bytes. So that means basically, if you don't have any data, if you don't have any optional fields, then the header size is 20 bytes. That is the basic or a minimum size of the header. Suppose if you send this IP version 4 without any data in the link, then it should carry 20 bytes of 20 bytes of the information that can be accommodated in this. It is not data, remember that. It is only some information which is there, but the options field and data field is also available in the 6th and 7th row, which is in total is representing 40 bytes. It is representing 40 bytes of information, so that so if you take the first 5 rows, it is 20 bytes. And fortunately, if you are also having some optional fields, and if you are also having some data which is covering 40 bytes of information, then the total, the IP version 4, the complete frame is going to accommodate 60 bytes of information can be seen in this total frame. So that is about the total size of the total size of the actual header format, which is representing in terms of bytes, how many bytes you can able to accommodate. So that is actually shown in this case of the actual frame format. Now you see there are number of fields, and of course if you see this this particular the partition, it is exactly half of the 32 bits. That means left side of the portion of this part, you are finding 16 bits, and right side there are 16 bits, totally 32. Again, this 16 bits is divided into actually some intersected. So let us say this is another important portion, and that is called as 8 bits left of this line, 8 bits on the left side and 8 bits on the right side. Again this particular left side portion is again divided into 2 portions, that is 4 bits, and another one is also 4 bits. That means this particular fragmentation is purely for the sake of the comfort of actually conducting the transaction in a successful manner. Now let us discuss about the role of each and every field in this case of IP version 4 header format. So for your convenience, just I am showing the row by row for identifying what field is there and how you can able to note down for what reason it is actually introduced in this IP header format. The first field is version, because we are going to have two types of IP versions, so that to be familiar about what type of version of frame we are using. So to make it clear that we are using version 4 or we are using version 6, to make it clear the version field is introduced, so which is basically filled with 4 bits. Generally if you are using IP version 4, it is strictly filled with 0100, which in the decimal notation it is actually comes to 4. In the binary notation it is 0100. So the version field is filled with 0100 statically, because we are going to use version 4 kind of frame format. So it fixed with 0100, nothing more than that, so that the router or any the host can able to identify which type of or what type of version of protocol you are using. So based on that they can do necessary arrangements to actually get the information and to forward the information from host to host can be carried out by the routers properly. Okay, now this next the other thing is called as header length. Okay, because the header length is a field that is used to exactly specify what is the size of the header in the current frame, because header size is a variable length, because sometimes it is the minimum length is 20 bytes and the maximum length is 60 bytes totally. Already I have shown that in the previous slide, because if you don't have an optional field, if you don't have any data, the header length is only 20 bytes, and your optional fields are there and also data is also there with some bytes, so the length will be more. So now exactly what is the header length, suppose if it is clear, so that we can identify the data part and the header part, so that you can identify the exact data from where it is starting in the actual datagram, because datagram is a portion of two. One is called as the header and the other one is called as the data. So this collectively referred as a datagram in our terminology. So a datagram consists of header part and the actual data part. So now because header is of variable length, how do you know that what exactly the size of the header? Because is it 20 bits 20 bytes, or is it 25 bytes, or is it 40 bytes? How do you understand that? So that this header length is going to specify what exactly the size of the header, so that based on that you can identify the exact data, so from where it is starting, for identifying the location of the data, to understand what it is. This type of service, this type of service is another important field, which is meant for represent other kind of prioritizations like this. For example, if you want to see what exactly the type of service is going to tell us, is suppose you want to note down, or if you want to see the actual the throughput, how the throughput is possible, what actually it is going to tell us. Similarly, what is the delay factor, and what is the reliability factor, and what is the cost factor. Suppose if you want to know, so whether if I follow this particular IP version 4 frame, so as far as the link is concerned, as far as the frame is concerned, how far I am able to rely on that. So that can be represented in the form of a type of service. Suppose if it is 1, so the throughput is high. If it is 1, the cost factor is high. If it is 1, the reliability is high. So whenever the bit is indicating as 1, it always says that it is that factor is high. That means basically the service may be of reliability, it may be throughput, or it may be some kind of cost. All these are various factors which tells about the actual the priority of using this particular frame for reliable service. So that is why this is another important type of service field is useful for us to give you more information about so how long you can able to rely on this particular service. And packet length, So this packet length is saying about what exactly the size of the data, because the packet length is another important thing where there is a header and there is a data. So exactly what is the size of the data we are actually able to identify in this particular packet. That means because header is a variable thing, that is a very basic thing you have to understand. Because header is variable, you cannot straight away say that so this is the fixed length I am always following. Because header is variable, you should specify what exactly the size of the packet that you are using. So for your information, just I am showing the maximum size of the that packet length that in terms of bytes is mentioned here, because it is of 16 bits of size. Okay, if you calculate 2 to the power of 16, it comes to 65,536. If you calculate that, you get 65,536 bytes. But we are starting from 0 onwards, so it is calculated as 0 to 65,535 bytes of you can able to put the data in this particular packet length. So this is the way how you can able to use the concept of packet length to understand what exactly the size of data that is there in this particular frame. And next is identification, flags and offset. This is another important thing that you have to consider. So the 16-bit identifier is another important factor. So here this is related to fragmentation, because 16-bit identifier is going to tell us whether the packet is fragmented or not, because the whole packet may not have the total message, so that the packet has to get some fragmentation. So this particular 16-bit identifier is going to say that whether the data is fragmented or not, that means the packet is fragmented or not, related to fragmentation of large datagrams. Suppose the datagram is very large, which will not fit in the prescribed frame, then what you have to do, you have to definitely divide that into by taking number of frames. You put the relevant data based on the boundaries, or based on the actual the characteristics that are there. You have to fill the data in that, and based on that the datagram is actually taken into different fragmentations. So that is why this fragmentation is done or not, that you can able to identify in the 16-bit identifier. And it is also used to reassemble them at the destination. Why? Reassemble is another important phenomena by which so the fragmented portions can be collected by number, so that they can be forming the original message, so that at the destination you can able to identify the total message at a stretch. So that is the main purpose of reassembling the fragmented parts in by following a reassembly technology. So now in this case of one more point, I am going to say the flags. The flags are actually basically of 3 bits of size. So the first bit is generally 0, which is reserved for future use, and the second bit is actually it may be 1. Suppose if it is filled with 1, second bit is filled with 1, then it says that so don't fragment the datagram. Whenever the second flag bit is 1, so it indicates that no fragmentation is recommended here. So that is about the second bit, which is filled with 1. Suppose the third bit, if you consider, it may be 1 or it may be 0. Suppose if it is 1, more number of fragments are there, so it indicates more number of fragments are there. Suppose this MF, that means more number of fragments bit is 0, then it indicates that is the last frame in the actual the sequence. So this is the information that you can able to get. And 13-bit fragmentation offset, because the fragmentation is done, then you may be in a confusion that exactly where the data is existing. So for that the 13-bit fragmentation offset is going to give some clarity. And there is a time to live field, this is shortly called as a TTL. This is something called it is actually a 4-bit field, which is going to have some number. And once actually the datagram is traveling by taking number of hopes, from hope to hope the value will be decremented, and finally it is going to reach to 0. because once it is coming to 0, then if it is not received by the receiver, then the packet will be dropped. Suppose before reaching to 0 or exactly by reaching to 0, suppose the packet is reached to the destination, then automatically the data will be received by the receiver, and that is the way how you can able to see the time to live, okay, or TTL field that is useful for us to identify how many hops are taking place, and it will be decremented so that exactly the TTL value is becoming to 0 by the time the packet should reach to the destination. That is actually the meaning of time to live. The upper layer protocol. This is another important protocol, indication, where because we are in the network layer, the IP we are talking about is IP network layer, and above that there is a transport layer, and transport layer may use certain protocols called TCP or UDP. So suppose the information is related to the transport layer protocol, like TCP or UDP, then it indicates the information like 6 or 7. It says, suppose if it is saying 6, it says about TCP protocol. If it is saying about 17, it says about the UDP protocol. Like this, the information can be related to the upper layers. The protocol information will tell you about the upper layer protocols, to which protocol it is going to prominently using, by taking into consideration about the upper layer. And header checksum. So this checksum is a criteria which is used to find out the errors in the transaction. Suppose any error is occurred during transmission in the data, so that can be identified by following the header checksum value, so which is useful for us to identify the error is occurred or not. That extent only you can able to say about the role of header checksum. So it is for checking the error or finding out the error is taken place or not. And source and destination IP addresses, which is of 32 bits of address part is taken into consideration, and this 32 bits is basically divided into 4 parts. That means by taking every part as 8 bits of size, that means 8 bits, 8 bits, 8 bits, and 8 bits. So this is the way how the source IP address can be classified, and we will see in the future lessons how these 8 bits can be called, and what is the role of the first 8 bits, leftmost 8 bits, and what are the other notations that are actually given for the other 8 bits of portions that are there in the IP address, that we'll see in the other sessions. And similarly, the 32-bit destination IP address is also there, which is also just like the source IP address. It is also of 32 bits, and it is also of 8 bits, 8 bits, 8 bits. 4 8 bits of portions are there. So this is also useful to identify exactly the destination device. And optionals field is another important field, which is going to give more and more special functions. Suppose if you want to indicate in the overall frame, so this optional field is used to indicate that in the optional field. And data payload, this is the exact data size. That means it may be of because the data may be of variable length. So because the data, once you are fragmenting, so you cannot say that every fragment will have equal size of data. So depending on the exact size of the data, we have to put the data here in this data payload, and it should actually be incorporated along with the total frame, and it will be carried out along by making it as an envelope, that is called the header, because data is to be covered by some kind of a header, and the total the datagram will be traveling in the actual the link. So this is the way how the IP version 4 protocol is used to send the information. So that is the actual lesson today. So by this I am saying that the student is able to know what actually the importance of internet protocol fundamentals, and how IP addressing is playing a role, and what is the structure of IP version 4, and also the role of each and every field in this IP version 4. Thank you.